All right, now I want to go back to the problems we were just doing and work on the graphs for them. All right, so let's go back to question number 9. Okay, this time what I'm going to be focused on is how do you wind up with the graphs for these, okay? All right, so after you get this information, you get started by getting all that key information onto your coordinate plane. All right, so we know there's going to be a vertical asymptote at x equal 2, vertical line where there is no point on that line, okay? So that's going to be a break in the graph there. All right, then the horizontal asymptotes at y equal 3. So up here at 3, draw another dashed line representing the horizontal asymptote, which will be the end behavior of the function. Then plot your x-intercept. It's at 1, so you know that the graph crosses at 1, and that's the only place it crosses. And then it crosses the y-axis at 1.5, so you'll have a y-intercept up there. All right, now, in order to get this graphed, you don't have a lot of experience with rational functions, so you may want to find a few additional points. We kind of should know what's happening over there, over on this side where we have these intercepts, because the behavior of a function near an asymptote is that it starts hugging that asymptote. So I'm fairly certain that this is going to do that. Then it's going to go here and start getting closer and closer to that asymptote. All right, now, for what happens over on the right side, there's no reason why you can't put an additional number or 2 in. You can find some additional values. You know, maybe if you're not sure what's going on, put in a 3 over there to the right of that asymptote, and then work it out. So I'm putting the 3 into the function. When I do, won't I get 9 minus 3, which is 6 on top, and then 3 minus 2, which is 1, so I'm going to get 6, okay? So that means here, 4, 5, 6. At 3, I'm going to have a point up there, okay? Let me try one more. Let me try, say, 5. If I put in a 5, I'm going to get 15 minus 3, that's 12 on top, and then 5 minus 2, which is 3 on the bottom. So when I'm out here with an x of 5, I'm going to wind up being at 4. 1, 2, 3, 4. So I'm going to wind up being here. So that helps me to get the gist of what I think is going to be happening. It's going to be coming in like that. And on the other side, I can't draw it very well, but imagine that continuing on up. It's going to hug that asymptote. I just can't draw it because I didn't leave enough room. Okay? And there were no holes. All right, let's take a look at the graph for number 10. We've done all the work. We're just now trying to get all that onto a coordinate plane. So draw your coordinate plane. You're going to have a vertical asymptote at -2, so get that on the graph. All right, the hole, I think I'll wait to do the hole until later. Y equals 0 is the horizontal asymptote. That means right here at the x-axis, I'm going to have a horizontal line. Okay. So this is my vertical asymptote. This is my x equal 2, -2, I mean. And then this green line here turns out just to be the x-axis. That's the y equals 0. All right. It does not cross the x-axis. There are no x-intercepts. And then it crosses the y-axis at 1/2. So let me put a couple tick marks on here. It's going to cross like right there. All right, so I don't have a lot of data to go by. I do know over here at 1, with a y-coordinate of 1/3, so really close to that, there's going to be a little hole in the graph. So I'm going to go ahead and find a few additional things. I might want to look at what happens when x is -1, because I think I know what's happening here. It's going to be doing this and then hugging the x-axis there, okay? And then it's probably going to be going up, but I just want to get the gist of that. So let me show you a -1. So remember the original function had an x minus 1, so negative 1 minus 1 would be negative 2. Plugging negative 1 into the denominator, I'd get negative 1 times itself is 1, minus 1, minus 2. So this turns out to be negative 2 divided by negative 2. So I get a y of 1. All I'm doing is plugging in my x values into the original function. So for when x is negative 1, I'm going to be here. So I think it's going to wind up doing this. It's hard to draw because it's weird how my computer is set up right now. But it's going to go and get closer and closer and closer to that asymptote. And it's coming down here and getting closer and closer to the x-axis, just never crossing it. And here I have a hole at 1/3. Okay. All right, now, there's another piece to this, though. We just don't have any data for that area. So I'm going to look over here at like negative 3, maybe negative 4, somewhere in there. So if I plug a negative 3 in, I'll go ahead and show you what I'm doing. I'm doing that on top, then I'm doing negative 3 squared plus a negative 3 minus 2. So I wind up getting a negative 4 on top, and then 9, take away 5, that would be positive 4 on the bottom, and that's going to wind up being a negative 1. So negative 3 is going to be down here at negative 1. Now, once you get used to it, you'd probably then know what's happening, and you'd be able to do the rest. I'm going to put a negative 5 in and show you what you get when you do that. So negative 5 minus 1 over negative 5 squared plus a negative 5 minus 2, that would turn out to be a negative 6 on top, and then 25 minus 5 would be 20, minus 2 would be 18, and I'd wind up with a negative 1/3. So when I'm out at negative 5, I'm even closer to the x-axis, but on the bottom. So I'll be right there. So what this is going to be doing is hugging the x-axis from the bottom and then approaching the vertical asymptote. Okay, don't have it curved back in. Kind of had it curved back in. It's really approaching it and continues to get closer and closer and closer to those asymptotes. Okay. All right, let's try graphing 11. All right, so with 11, we have 2 vertical asymptotes, one over here and one over here at negative 2. Okay, so x equals negative 2 and x equals positive 2. We have a horizontal asymptote right there at the x-axis because the degree was bigger on the bottom. Okay. This is my y-axis, this is my x. Okay. All right, let's see. It's going to cross the x-axis at 0. Okay. That's going to be both an x and a y-intercept. And right now, that's all the data I have. There's no holes or anything like that. So you're going to need to plug in a few more values. Okay. So let me move this over just a little bit so I have room to do a table to know what's going on. Now, I'm just going to plug in a few things. I'm going to look at what's happening when I'm over here at like a negative 3 or negative 4. Okay. When I plug in a negative 3, I'm looking at that expression, plugging in a negative 3. I'm going to get a negative 9 on top. Okay, so when I plug in a negative 3, I get a negative 9 on top. And then when I square the negative 9, it becomes 9 minus 4. So I'm going to get a negative 9 over 5. So that's like negative 1 4/5, so almost negative 2. So when I'm at negative 3, when I get to negative 3, I'm going to get to negative 1. I'm going to be down here, almost at negative 2. Okay. All right, and then you could try maybe a negative 4, see what's happening. So you'd come in on your calculator and just replace that with a negative 4 and see what you get. So when you plug in a negative 4 in each of those spots, negative 4 there, you get a negative 12, and then 16 minus 4 would be positive 12. So you'd get a negative 1. So remember that the x-axis is an asymptote, so it makes sense. This is doing something like that. And then you might guess that it's going to do the same type of thing it normally does at a vertical asymptote. Now I need to see what's happening in between the two asymptotes. So now I'm going to go in and maybe plug in a -1, and then I'll plug in a +1. If I plug in a -1, I get a -3, and then +1 minus 4 would be -3. So when I'm at -1, I'm going to be up here at 1. Okay. Okay. Now I'm going to plug in a +1 here and here. When I do that, I still get a -3 on the bottom, but I'd have a +3 on top. So this will be, when x is 1, I'll be down at -1. Okay. All right, now it's not going to be a line because when it approaches an asymptote, it hugs it. So it's going to curve a little bit, something like that. Okay. All right, now we're going to go over here. We're going to look at what happens when I plug in a +3, maybe a +4. So when I do a +3 in here, so what we're really doing is just kind of creating a T-chart, but I'm just graphing it as I go. If I plug in an x that's +3, I'll have a 9 over 9 minus 4, which is a +1 4/5. So when I'm at 3, I'm going to be up at 1 and close to 2, 1 4/5. And then when I plug in a 4 there, I bet you I get something similar to what I got when I plugged in a -4. I get a 12 on top, but I also get a 12 on the bottom, so it winds up equaling 1. Okay? And so that's when I'm at 4, then I'm at 1. So it has a little symmetry to it, and I'm going to wind up having that look that way. Okay? So we just did a T-chart. We tried a few things like -3, -4. Then we did a -1 and a +1, and then a 3 and a 4. And we're just plugging into the original function to get a few additional pieces of information so we can sketch the graph. All right, I want to graph one more. Okay, this guy here. All right, so x equal 1 is our only asymptote. We don't have a horizontal, our only vertical asymptote, and then we don't have a horizontal one, and you're really not supposed to know, you're not really taught how to get slant ones, but it's actually going to have a slant asymptote when we get finished. It has 2 x-intercepts, crosses the x-axis at -3, and it also crosses it at 2. Okay, and there's a y-intercept up here at 6. Okay. And so we could put in a few more values to kind of see what's going on. So we could do the T-chart idea. So we could do this, and we could look at, okay, well, what if I'm over here at like -4, and we could plug it in and work it out. So I'm going to go to here. I could plug in a -4, square it, plus a -4 minus 6. Okay, over -4 minus 1. So I'd get 16, take away 4, which is 12, take away 6, which is 6, over -5. So I'd be at -1 1/5. So when I'm over here at 4, I'm going to be at -1 1/5. Okay. All right. So I'm not sure, but I know when it approaches a vertical asymptote, it kind of hugs it. So I'm thinking it's going to have to do something like this and then hug that vertical asymptote. It's just this way is what's going to be harder for you to do since we didn't have a horizontal. It never approaches some horizontal line, so it just keeps getting smaller and smaller and smaller. Okay. Now I'm going to test a few things over here, over on the right, like maybe a 3 or a 4. So if I put in a 3, let's do 4, because I've already got the 4 there, but it would all be positive. If I plug in a 4, I'm going to get 20 minus 6 going to get 16 plus 4 is 20, take away 6 would be 14, and in the denominator I'd have a positive, so it'd be 14 over positive 3, so that's going to be a positive number, and 3 goes into 14 4 times, and an additional 2/3. So when I'm at 4, I'm going to be at 1, 2, and 2/3. So somewhere like that. And if I were putting a 3 in there, then I'd have 3 squared plus 3 minus 6 over 3 minus 1. That would be 9 plus 3 is 12 minus 6 over 2. That's going to be at 3. So 3 would be at 1, 2, 3. Okay. 1, 2, 3. Okay, I don't think I plotted that as high as I should have. It was 4 and 2/3. So when I was at 4, I should have been at 1, 2, 3, 4 and 2/3. So I should have been up a little higher. All right, and then I know when it approaches an asymptote, it should hug it. So it's going to be coming in and doing something like that. You could plug in 1.5 if you wanted to or felt like you needed to. And that would be it. Now, this is what the slant asymptote would be, but you don't really have to do that. But that's why this graph looks a little different. What would happen if I were to graph that is I have a line. The asymptote isn't horizontal. It's linear, but it's going to be a slanted line like that. And so what's really going to happen is this function is going to start getting closer and closer and closer to that as we pick numbers. It'll start approaching it that way, and then this way it starts getting closer and closer to it, to the asymptote. Okay, I just wanted to show you one of those, even though you don't really have to do the ones that have slant asymptotes. Okay.